Director PS, all the HODs, CRCs, all the officials joining from other oil and gas companies, a very good morning to one and all present for this webinar. My name is Anupriya Sharma. I am Deputy Director Industries at PCRA. On behalf of our entire team, we would like to extend a warm welcome to our esteemed speakers for the day. Welcome, sir. Now, with Pandey sir's permission, I would like to start the session.
Sure.
Okay. Thank you, sir.
Thank you, sir.
Okay.
So, the Waste to Wealth mission is one of the 9 scientific missions of the Prime Minister's Science, Technology and Innovation Advisory Council, PMSTIAC. The mission is spearheaded by the Office of Principal Scientific Advisor, PSA, Government of India. This aims to identify, develop and deploy techniques to treat waste to generate energy, recycle materials and extract resources of value. This mission also identifies and supports the development of modern technologies that promise to create a clean and green environment. With this brief introduction of the subjects, I would like to brief about today's session. So there will be 3 presentations today, approximately 15 to 20 minutes each, and followed by a Q&A session. So it's an honor and a pleasure to introduce our esteemed speakers for the day. So starting the session, we have Dr. Sunil Pandey from TERI. Dr. Sunil Pandey is a Senior Fellow and Director, Environment and Waste Management Division, TERI. In addition, he is also working as a Director, Emerson Center of Sustainability and Adjunct Faculty at TERI School of Advanced Studies, TERI SAS. He has more than 30 years of consultancy, research experience in the areas of municipal, industrial, and hospital waste management. Their linkage with climate change aspects and circular economy and resource efficiency, waste to energy issues, impact assessment, air, water, and soil quality monitoring, site assessments, performance evaluation of ETP, institutional strengthening, and capacity building. He has obtained his PhD degree in hazardous waste characterization from Nagpur University while working as a project fellow at NEERI Nagpur. Prior to joining TERI, Dr. Sunil has worked for ERM India and at the Hong Kong University of Science and Technology on development of landfill liner for containment of land disposal hazardous waste and delivering material balances and associated environmental pollution for Hong Kong region as a part of his postdoctoral research. A warm welcome, sir.
Thank you, Anupriya, and for kind introduction. So without further ado, I'll start my presentation, and let me start sharing it. Let me know if you can see the presentation.
Yes, sir. The presentation.
Yeah, sure. Thank you. So what I'll do is today's session, the sub theme on the waste side, which I thought I'll select and discuss with you, is not so much on technology viability, but more on a dry waste management. And what has been, if you look at municipal solid waste, we talk of dry recyclables and wet waste, which goes for composting and which goes for biodigestion. So I'll discuss about dry waste and what's the international scenario and how dry waste is managed in an international scenario. What are business opportunities, and then what are some of the good successful case studies in Indian context for the dry waste management. Why we are, I mean, this slide actually discusses on why resource recovery is required. Why are we bothered about recycling and recovering secondary resources? Is for the fact that if you look at this exercise, which is generally done by Footprint Network globally, every year they look at how much resources are available and how much we are using, and in what month we use the resource, which is actually should be used over the year. So if you look at the last bar 2022, it says that around July, we have used all the resources which are supposed to be used by December. So and trend is though it is increasing, but has, consistently it has been same that from the very beginning we have been using resources much faster than we should have used. And also, if you look at on the left hand side, it shows 1 Earth, and on right hand side it shows 1.7 Earth. So what it means is now to meet our resources from the primary sources, mining and primary sources, we now require 1.75 Earths. 1 Earth is not sufficient, and that indicates that we cannot only depend on our primary material supply, and we have to look at recovery from waste which we have already produced and which we have already generated, and how basically we can maximize that so that secondary resources which we extract from this waste can partly meet the demand of the primary material. And in that, recycling is an important aspect. And there have been studies which have shown that if you look at recycling and simple dumping of the waste, dumping the same amount of the waste, if you see top, it creates 6 jobs. While recycling the same amount, if the waste is recyclable, creates 36 jobs. And not only that, uh, uh, recycling also creates additional jobs which are created in recycling are at higher income level if you compare that with dumping. So it also, I mean, it is established that it also creates a quality job when you're looking at recycling, and they're all green job creation, which we all talk about. Just to give you some trends in Europe for the most of the countries, if you look at the packaging waste, which we have been now talking of, this is data for 2020. Packaging waste recycling, recovery and recycling has been reported at 64%. There's a slight dip in recent years, and as the graph shows, and that is understandable because I mean we all know that last few years we have been amongst the COVID and pandemic and lockdown and sudden increase in use of single-use plastic material, also such material which increases the plastic waste. Packaging waste, when you say packaging waste, it's mostly plastic. Municipal solid waste recovery and recycling has been reported at 49%, and overall recycling on an average is around 46%. So that's kind of scenario. That's a kind of benchmark which we look at when we look at recycling and the level where countries have to reach. If not 100%, 100% sometimes is not practically possible. But what are the levels which are desirable? When you look at world's recycling industry and the market, how recycling actually also affects not only job, but also the kind of economy, economic resources it generates. So globally, when you see around 1.6 million worldwide people are active in recycling industry. So recycling is a really global phenomenon. And together they handle around 600 million tons of recyclable waste every year. And annual turnover in the recycling business, I'll also give you who are some of the major recycling companies globally. The annual turnover is around 200 millions, which is very similar to GDP of countries which you can relate with, countries like Portugal, Colombia, Malaysia. Important to note here is that whatever profit these companies make, the 10% of that, roughly 10% of that is plowed back to developing new technologies, developing new environmental standards, developing research and funding towards research and development, which further creates high-skilled jobs. And globally, if you look at what's the percentage of secondary material which is recovered through recycling, it meets around 40% of the global raw material requirement. So globally, 60% comes from primary material supply from mining majorly, and 40% comes from secondary material supply. So that's a important, that's a contribution which recycling industries are making. And these are some of the global industrial giants. Though recycling business had taken a hit in the last few years because of the pandemic. But you all, I'm sure a lot of you might be familiar with companies like Veolia, a French company like Suez, another French company based out of France and now very active in Europe, and also waste management company, which is company in US, and how they fare in global business companies list. So what I'll do is from there, looking just to give, this was to give you flavor of why recycling is important and why one should look at recycling as an opportunity, and what's a global discourse on recycling currently. And it's already established when you look at, say, recycling, except for plastic packaging material in some cases. It is already established that recycling of, say, for example, metals or recycling of, when I say metals, it's largely aluminium and copper, and recycling of glass, though it is more energy intensive, because primary production of glass itself is more energy intensive. They save around 90% of the energy when you look at mining them from virgin resources and producing a product. Plastic is slightly lower. It's saving around 65% energy. But it is established that when you look at recycling, it's more, not only less energy intensive than from producing virgin material, but also since they are less energy intensive, they also help in meeting your climate goals, because that saves that much energy when you recycle, and that much greenhouse gases emission are reduced. So now I'll give you some examples. Many of you, I'm sure, might be familiar because you are from petroleum industry. PET, for example, PET waste, how it has been recycled in India currently. And PET was one waste type which was not recycled much, say a decade back. But now situation is such that since a lot of value-added products are produced from PET recycling, the PET industry, PET packaging users, they themselves mentioned that around 90 to 95% of PET waste which is currently put in market is recycling. And how is that done? Once you receive the waste, you flatten them, you bale them based on color, based on end usage, what kind of products are packed in that, and then you send them for recycling. And what is done at the recycling end? These are cut, shredded, and then drawn into fibers, PET waste. In India, we don't do bottle-to-bottle recycling because there are FSSAI restrictions, food safety restrictions, that food cannot be packed in a recycled bottle or recycled packaging. So currently, it is all PET fibers, all used for making such value-added products, which you can see. Sofa upholstery in the automobiles, soft toys, carpets, gloves, such materials. In fact, a lot of it also goes into fabric manufacturing. A lot of companies intentionally mix 10 to 15 to 20% of PET, recycled rPET, which is recycled PET, into their fabric manufacturing. So clearly, there's a recycling value in the PET. This is a site where what is happening is it's a large composting site where wet waste is taken for composting. But what happens is this is a clear example of if the segregation is not proper and if the segregation is not efficient, then while producing compost on the right hand side, if you see, these rejects come out, and these rejects are largely. It's not very difficult to make out. They're all plastic packaging, they are clothes, rags, things like that. And what happens is these cannot be composted. They're not biodegradable. So what is to be done with that? So one option which one entrepreneur has shown that these can be cleaned. These can be cleaned and then shredded and produced into fuel and fuel briquettes rather. And how these fuel briquettes look like. This is a kind of fuel briquettes which are produced from such dry waste, which is cleaned and shredded and then extruded into fuel briquettes. Advantage of producing such fuel briquettes now is they can be easily handled, they can be easily stored, bagged, transported. Rather, I mean, if you compare that with the original condition in which they were, and now they have consistent calorific value. So they can they can be really easily used either for industrial purposes, but in India there's a lot of action now happening on using such fuel briquettes in cement plants, and cement plants are looking for such alternate fuel material which they can use in the kilns, and in the process they can save coal while producing cement. And advantage of using that in cement plants: cement kilns have high flame temperature inside the kilns, so that ensures that complete destruction happens. There's a good residence time, more than 5 seconds, and it's higher than conventional incinerator. If you see, incinerator is between 2 to 3%, and it's more than 5% in the cement plants. That also ensures that no dioxins and furans are generated, which is the one major concern when you burn the waste in the waste treatment plants. Also, since the cement kilns have they use lime and they have alkaline atmosphere in the kiln, so any acid gases which they generate is also neutralized by the alkaline environment which is there in the cement plants. And biggest advantage is that the waste derived fuel which you use is consumed in the cement manufacturing process, and there's no ash coming out, there's no residue coming out, so it becomes part of the cement matrix. The plastics, this is something which has really caught up, and a lot of construction now have happened. NHAI has also used millions tons of plastic, but initially it started with a few such experiments. For example, in Jasco, Jamshedpur township, run by Jasco, and a few roads in southern India where it started. The plastics which are too dirty, or I mean, if they cannot be recycled. For one example, a clear example is multi-layered plastic, which is not recyclable. So they can be shredded again and they can be mixed with bitumen, and such roads are laid using such plastics. And results have shown that these roads last much longer. In this experiment, for example, when we visited them, they said that this road was good for at least 5 years. They were using that without any wear and tear. So there was a clear example on how this can be used very safely in the road construction. When I said multi-layered plastic, one particular example in multi-layered plastic is Tetra Pak, which we all are aware of. Why how Tetra Pak is used in packaging. And interestingly, if you look at different layers in Tetra Pak, what they comprise of, Tetra Pak largely comprises of paper, and paper is around 75%. 20% of that Tetra Pak carton is a polythene, and 5% is aluminium. And this is how they are arranged in the typical Tetra Pak carton packing. Inside, two layers are polythene because you need permeability. Also, you need impermeability. I mean, you need good oxygen barrier, and the things which are packed should not interact with your packing material. This is followed by a layer of aluminium, and followed by then again a polythene layer and a paper layer, and outside also is polythene layer to protect all these packaging. Idea is to keep material safe, but problem happens is when you look at the cartons when they become waste, because it's not easy to handle this. Even if you send it to paper mills, which are using recycled paper, when this is pulped, paper is recovered, 75% paper is recovered. But what to do with 20% polythene and 5% aluminium? They come out as together as something which we call polyal. It's a mix of aluminium and polythene, and it's called polyal. So what Tetra Pak has been experimenting is how this polyal, because paper is something which can be recovered and which can be reused, how this polyal can be used in a useful application. So one of the applications which they have been looking at, sorry, is making such corrugated sheets. I mean, it is heat compressed and made into such corrugated sheets. And you can see the shiny portion of this is actually aluminium, and largely it is polythene with some binders, which a minimum amount of binder is required to bind them and give them shape into roofing sheet material. Advantage here is it's like unlike concrete roofing sheets. These are much lighter, much stronger, and they can be like they can also be you can drill hole in them, and you can use them in construction application. And there's no effect of moisture, humidity, and they don't get degraded. But only thing is marketing of such products is required, and one needs to see how such recycled product can be marketed. So with this, a small description on how our own recycling in informal sector is happening. And this is one example from Dharavi. You all know it's one of the largest slum settlement in Mumbai, in Asia, and how they have been looking at recycling, and they recycle large part of Mumbai's waste, which is generated. 80% of Mumbai's waste is recycled in Dharavi. And these figures give you some statistics on how much is the revenue they generate on an annual basis, around $1 billion each year, and employing around 1 million people in the business. And it's a vibrant recycling operations in Dharavi. So even at the informal setup, recycling's value of recycling has been established and recognized, and they do a lot of recycling in such manner. So with this and the message that the ultimate aim of all this is basically, as Honorable Prime Minister also said a few months back, that ultimate goal of all this exercise should be to create garbage-free cities or landfill-free cities. Because we know, I mean, those who are from Delhi would know that how in winter times, how in summer times these landfills start burning and start smoking, start producing smoke and start contributing to pollution. And why, I mean, and also they become nuisance in the city landscape. So why there's a requirement for creating such landfill-free cities. I'll stop here. Thank you so much for your patient hearing, and we'll take up the question in the end if there are any. Thank you so much.
Thank you, sir. Thanks a lot, sir. Thanks for the insights of the waste industry, not only briefing about the world's recycling industry, but also giving some very interesting examples about India. So we would also like to share that in recent India Energy Week 2023, IOCL has also launched a project of making uniforms for the frontline workers from PET bottles. So great insights, sir. Thank you so much.
Welcome.
So, yeah. Moving to the next session of the day, I would like to welcome and introduce Shri Pradeep PR. Mr. Pradeep PR is a chemical engineer holding MTech degree in chemical engineering from IIT Delhi. Over 13 years of professional experience in the research and development areas related to resin upgradation, waste to energy, plastic recycling, needle coke, biomass processing, and crude to chemicals, etc. He played a key role in the development and commercialization of cutting-edge in-house refining technologies such as Nicomex, Eco P2F, Incoker, and DCU revamp. He is currently working in the area of heavy end processing research domain of Indian Oil Corporation Limited as a senior research manager. He has 17 granted US patents in his name and 3 international journal publications to his credit. Warm welcome, sir. Over to you.
Yeah, thank you, Ms. Anpriya, for the introduction. And I thank PCRA for giving me this opportunity to make this presentation in this webinar. And let me share the slides. Yeah, I hope it is visible.
Yes, slides are visible.
Yeah. So I also thank Dr. Pandey, who presented a very nice presentation on waste to wealth and the importance of recycling and the amount of impact actually that creates in the society, as well as that's the livelihoods of people. So I come from Indian Oil Corporation. So many of the participants here, as I am told, are from oil and gas industry. So here actually I would like to introduce to you about a technology which we have developed and demonstrated in commercial scale at IOCL, that what we call as Indian Oil's eco-friendly plastic to fuel technology. We call it Indico P2F. So as you all know, actually, the plastic waste is a very critical component of the MSW waste. And considering the consumption of waste, consumption of plastic in India, which is almost like 1/4 of the global average. So as we go on the developing path, actually the plastic waste is going to increase in India, and there are actually requirements of different pathways to handle this waste. So earlier speaker has mentioned several such routes for handling waste. And what we believe is that there is no single technology which can address all the problems, and there is always scope for new technologies. And here we are introducing Indico P2F technology, how the refineries can play a role in handling plastic waste. So this is a brief background on this presentation. So I will just briefly discuss on the waste plastic scenario and what are the initiatives that in Indian Oil we have taken for waste plastics and ensuring plastic neutrality. And I will then move on to the Indico P2F technology features and other benefits. Then what approach we had adopted in our laboratory as well as in the pilot scale, and moving on to the commercial demonstration. And I'll make a summary of that. So if you see the global scenario, there is a considerable amount of plastic consumption, more than 300 mmTPA, which generates more than 150-140 mmTPA of plastic waste. And lot of plastic waste is getting ended up in the landfills, and some part is getting re-incinerated. So even in US, this due to the high plastic consumption, this problem is a very big menace in even the advanced developed countries. So in India, actually, as I told earlier, in India, the scenario is also going in the similar lines as our GDP is increasing, as our income of average Indian is increasing. The consumption of plastic is also increasing. So as of now, around 9.5 mmTPA of plastic waste is generated. And out of that, India is one country where recycling is at a higher level compared to other developing countries. Because recycling or reuse is in our culture from, you might be knowing, like our ancestors, even our grandparents would have told you that, okay, don't have like much materialistic things from outside and live a contented life. So this kind of philosophy is there in our Indian culture. So we actually don't generate much of a burden to our Mother Earth. But still, it is a sad scenario where we can see that around 40% of the plastic waste is left uncollected. And mainly it is going into landfills and the mountains of this waste that situates in the neighboring areas of our cities. So plastic growth is around like 1.4 times of GDP growth. And in the future, actually, you need more technologies to address this problem. So out of the plastic waste, actually, majority of the plastic waste is the packaging waste. And in that, the multi-layer metal additives packaging contributes to a higher degree. And there is no much cost-effective process available for conversion of this kind of waste. So when you go for incineration of the waste, what happens is that there are a lot of additives that are added in the plastics, like to improve certain properties. Suppose you need fire resistance. So add some boron-based compounds. This kind of different compounds are there which enhances the properties of plastic. So while this gives a benefit in terms of usage of plastic, but the end of the life, these actually creates the biggest hurdles in recycling. If you go for incineration, you can see a lot of toxins, lot of particulates, lot of harmful gases that would be emitted from incineration. So there is a need for a benign process to handle plastic waste. So in this aspect, actually, Indian Oil has adopted several approaches. So as Madam also told about a recent approach, the PET bottle recycling into clothes. So similarly, in R&D side, we have done chemical recycling initiatives, how to produce specialty wax from that, how to convert polystyrene waste to styrene monomer, and different type of packaging that is being produced from waste plastics. So this kind of even the roads. So the roads also now several companies have done this aspect, and we have also some initiatives in this area. And even the biodegradable plastic side, actually now the research is going on. So maybe we'll come out with some products in the near future. So our focus mainly was on the chemical recycling part and how using the existing infrastructure in our refinery industry, we can handle this waste, because setting up an entirely new infrastructure, new plant is a costly proposition. And the low hanging fruit for the refining industry is to look at what are the available infrastructure or the assets which can be used to do this chemical recycling. So in this actually journey, we have come out with this idea of this technology, Indico P2F. So what we looked at in our team is that we were working on residue upgradation, and we were looking at the ways in which we can add value to that particular process. And what we have identified is that if you consider a delayed coker unit in a petroleum refinery that operates at a typical operating temperature of around 500 and an operating pressure of ranging from 1 to 3. So what we found is that these conditions are ideal for cracking of plastics. So there are several literature data, several studies. You might have even heard that from my childhood, I have been hearing also several news articles coming. Someone made fuel from plastic. So this kind of thing, actually, what we found is that there is a certain activation energy requirement for breakage of plastic, which is nothing but a polymer of different constituents, right? So if you depolymerize the plastic, whatever liquid that is coming out can be categorized into different parts of fuel. And our delayed coker is one of the units that we identified, which could be used for plastic processing. So in this, actually, we then came out with like a process, how to do that, because the idea maybe many people had, but how to do that in a commercial plant, that was a big challenge. Because as you know, from refining industry, we have lot of sensitivity in our feedstock. Like if there is a 1% difference in aromatics, your overall plant yields will go haywire. So these kind of things, and lot of impurities are there in the plastics. How to handle those impurities? How to do the processing without causing any harm to the hardware, without causing any choking problems, and without impacting your product quality. That is of paramount importance, because ultimately we have to make the fuels as per the specifications of the BS, right? So there are a lot of challenges. So step by step, actually, we studied each of these areas and we address these challenges through our technology. And we have come out with this patented technology where we are able to handle all types of plastics, including metal additized plastics to a certain extent. And what we have achieved in this technology is that we could convert 95% more than that of the waste plastic to mainly lighter distillates like naphtha and middle distillates. So as you know, naphtha is a very demanded product in the scenario of crude to chemicals. Wherever you have higher naphtha, you have higher petrochemical intensity. And even some of the middle distillates are now being thought of to valorize into aromatics. So this actually we found as a perfect fit for the future scenario of crude to chemicals as well as net zero, along with ensuring a plastic neutrality. So this actually what we the technology was formulated in such a way that we can go for implementation in existing delayed coker units by revamp. And the design was made so robust and capable of processing waste plastic on a need basis. Because this has another aspect, because there are a lot of graphs showing that so many MMTP of plastic available. But if you today you float a tender for 100-ton plastic, you will be surprised to know that there are very few parties you will be able to supply that requisite quantity at your doorstep. So that means that whatever technology you implement, it should have a capability that it should be able to tolerate the feed starvation also. Means it could happen that in one month you have an excess supply of plastic waste. Next month you don't have that many supply of plastic waste. And the other month the plastic waste quality is changed. So this technology should be highly flexible. So that we have achieved in this overall process. And these are the novel features, like as I told earlier, mainly we are focusing on PE and PP. And as you know, as Dr. Pandey also told, the PET is a highly recycled plastic. More than 91% of PET is recycled in India. So hardly you get any PET in the plastic waste as of now. So marginal amount of PET we can handle. And what we focused is that India specific, as I told, using our existing infrastructure without much of a modification, even though there are some hardware requirement in the technology, but still it is a simpler and lower cost hardware. And you can easily implement it in the existing running DCU. And here we have an advantage that the reactor goes offline in every other cycle. So we have ample time to implement the technology without hampering the regular operation. And another important thing for oil and gas is that you cannot reduce your feed throughput. Because if I say you process this plastic, but you reduce the throughput by 5%, it's not agreeable by the management, right? Because you need to maintain the crude throughput in the refinery. So this technology can give you a way wherein you need not reduce your unit throughput. And it overcomes, in particular, coker. Actually, what happens is that the furnace is a critical item. Furnace is a critical hardware here, but so we are not having any issue in the furnace due to the plastic processing. So that is another major advantage. And the amount of plastic to be processed can be varied. And it can be decided on a case-to-case basis based on the availability of plastic, based on the plastic quality. Suppose you design the unit for processing, say, 2% of plastic. That has a flexibility to even go for 0.2% of plastic also, which is the requirement in the realistic situation. So this is like an on-purpose technology. And if you see the concept to commercialization, we got the idea back in 2018. And we made a first presentation coincidentally on the World Environment Day, where 2018 some initiatives were also coming for this plastic neutrality. So after that, then this project got momentum and we went into micro scale, pilot scale. Then we have an in-house engineering team for demonstration of technologies and licensing. So we did the in-house development of BDUP, detailed engineering, and all the studies. Then we installed and commissioned this particular hardware installation in one of the refineries in Northeast of in Indian Oil, and we did the commercial demonstration. So waste plastic properties, if you see, actually it is a mixed plastic. It varies because this is where the catch is, because the waste means it has a very widely varying properties. So how to handle the waste, how to manage this, so that is the main challenge. And then in our micro scale studies, we did experiments with multiple feedstocks, multiple plastics containing different residues, impurities, etc. Some of the data I'm showing here. So you can see that actually even if you see the yield pattern also, when you add the plastic, actually your yield is improving because the plastic decomposition is easier compared to the vacuum residue decomposition, and the product pattern is also oriented towards the lighter distillates. So after that, we have a 1 barrel per day delayed coker pilot plant in our center. So that was used for carrying out the validation. So we did around 2.2 weight percentage of plastic dosing along with a high CCR VR. And that we have confirmed that there is a whatever we predicted from our micro scale that were validated along with all the product properties, etc. And then we moved on to the commercial demonstration. So this was the very significant step. Actually, this concluded very recently. This is the team, our team went on site to do the demonstration. So we sourced some waste plastic from northern region because the availability was in the northern region, but we had to conduct the trial in northeast region because of the unit capacity was smaller in that region. So which gave a more cushion for our studies. And we have achieved actually 95% conversion of the plastic into distillates, and the coke was around 5% contributed from the plastic. And out of the distillate, as we got in our pilot scale, very similar lines, we have got naphtha yields around 40-45% and middle distillates around 55 to 60%. And we conducted a series of trials for more than 2-3 weeks actually. And we have achieved actually stable planned operation and within the specification product properties. And here another advantage is that depending upon the cost of the plastic waste, actually you can even have a positive GRM improvement because in several of the waste recycling or this kind of projects, actually those are strategic projects because there is a mandate coming up and you will have to do it later on. But here, then we need to look at the technologies where even though suppose tomorrow some regulation comes for plastic recycling in refineries or something like that, we should look at the economics also. So here what we have seen is that even with a plastic cost of around 30 rupees per kg, we got a GRM improvement of around 14 crore per MMTPA coker capacity. So this technology has a lot of benefits, like it's like a cost-effective technology for, I can just off the top of my mind, I can say around 3 million ton coker. If you want to implement, it would be maybe less than 15 crore capex. So it's just a ballpark cost. So it is an easy implementation in existing disuse by revamp without any shutdown requirement. And it is a viable part of extended producer responsibility also, because now what is happening is that the responsibility of handling waste is being shifted to the producer itself. So in the future, we can envisage a scenario we may have to bear some of the responsibility because the plastic, even though we are not making the packaging, but we are the generator of this polymer monomers, right? So later we can expect the government also come out with some kind of regulation. So this technology fits into that future scenario. And it achieves a circular economy of plastic because the plastic journey starts from crude oil and in the refinery. So it comes back into the refinery itself. So it's like a circular economy that we are actually realizing. And as the previous speaker told, actually, this where the plastic is being recycled is by actually the bottommost strata of our society. So why the recycling would be done by someone? Why someone will invest in technologies to recycle? Only when there is a demand for whatever he is producing after the recycling, then only people will come out with investment, right? So we, as a oil and gas major, we have some responsibility to start this actually the wheel moving. Means we create a demand for this kind of recycled material using some technology, then people will come out with more and more recycling options. So that is actually going to create a lot of jobs and even in the logistics, supply, processing, even the better quality of life for the labor force involved. So summarizing, the Indico P2F is a need of the hour cost-effective, environmentally benign technology for conversion of plastic waste into fuel. And we have demonstrated it in a commercial scale. And it was first of the kind in the world. and we have presented it in World Petroleum Congress also last year. And this is actually a green solution under the waste to wealth umbrella, and it actually is in line with several of the government initiatives like Make in India, or be it the Atmanirbhar Bharat or the Swachh Bharat mission. So we as an oil industry, we can make some real difference in this plastic waste recycling by implementing this technology. And as I mentioned earlier, we have a dedicated team for technology licensing. So you can contact us. Actually, we will help with all the licensing or the even till the PGTR is over. So this would be a technology which will actually help the nation by addressing some part of the plastic waste pollution issue, as well as trying to reduce some part of the crude oil imports, because we are generating fuel from a recycled source. So thank you all. Thank you all, and Jai Hind.
Thank you, sir. Thank you. Thanks a lot for highlighting the ins and outs of the Ind Eco P2F technology. That was pretty interesting. Also, the approaches and initiatives by Indian Oil for handling various type of waste. Also highlighting the practical difficulties in implementation of any new technology, how the technology should be, flexible, and there should be the commercial demonstration of this technology. Lastly, also thanks for reminding us that it has been our culture and it has been our nature not to put much burden on Mother Earth. Now, moving from industry to academia, we have Dr. Sudipto Mukhopadhyay from IIT Jodhpur. Dr. Sudipto Mukhopadhyay is currently working as assistant professor at the Department of Mechanical Engineering, IIT Jodhpur. He is also affiliated to the Center of Engineering Technologies for Sustainable Development at IIT Jodhpur. His current research focuses on energy propulsion and environment using experimental as well as numerical methods. Before starting at IIT Jodhpur, he was a postdoctoral researcher at Eindhoven University of Technology and Delft University of Technology, Netherlands. He earned his PhD in turbulent combustion modeling at the university. His PhD research was based on combustion modeling technique, flamelet generated manifold (FGM), and was in collaboration with Rolls-Royce Aero Engines, Berlin. He also completed his MTech from IIT Madras and BTech from Kalyani Government Engineering College. Prior to his PhD at TERI Eindhoven, Dr. Sudipto was working in Engineering and Industrial Services Division of Tata Consultancy Services, a leading Indian MNC. He has around 7+ years of industrial experience in various domains, spanning many facets of the engineering consultant. A warm welcome, sir. Sir, yes, you are audible now. Yes.
And,
over to you, sir.
Good morning, and thank you for the introduction. So without taking time, I would just try to share the screen. Let me see. Okay. Just a moment. Yes. Okay, I hope the screen is visible now.
Yes, sir, it is visible.
Okay, yeah. So good morning, and I would like to thank the previous speakers from TERI and IOCL because much has been covered of what I intended to say, but I would just go forward with what I have thought to present today. This is more generic in nature, and I have avoided getting into a lot of technical details. So hopefully it will be of use to the audience here. So the thing that I want to talk about is, of course, linked to what others have talked about, waste to wealth. And if we see that what is waste? Waste is something which we think that we have is to be discarded or is worthless and of no use. And what is happening today is that this concept of waste to wealth is telling that what we consider as waste is probably not waste, but is actually wealth that we are actually discarding. So that is the concept. And if you look here, what are the sources of this waste? So we are engaged, as a human civilization, we are engaged in many activities for the advancement of our civilization, like mining, agricultural, industry, construction, and as a result, and also along with that, we have the household and our waste coming from the household, as well as we have the waste water coming from the industries and households. So all these are sources of waste, and that is being discarded. Most of it is being discarded currently to be absorbed by the environment around us. Okay. And if we want to categorize these types of waste, the major types of waste, for example, municipal waste is becoming a big challenge, shortly called as MSW. So this is a waste which comprises of a wide variety, of different types of materials like organic, inorganic, all those sorts of materials. And this is becoming a growing challenge and problem, which we are to some extent maybe realizing and not maybe realizing also, but in coming years, it will be a big problem. For example, if you look into the scale of the municipal waste disposition. So if we talk about the oldest dump site that happens to be in Mumbai and set up in 1927. So this is the size of this dump site is almost around 247 football fields. So that is the massive amount of area that is being occupied to treat this municipal waste. And as our cities keep on growing, and we are, the population is growing, the cities are having more density in terms of the number of people, the municipal solid waste generated is becoming a big challenge. That what to do with that, and is it really a waste, or can we get something out of it? Okay, and if you see here, these are quite old statistics, but as you can see that the amount of waste generated also depends, or it's keeping on growing. And of course, as my previous speaker mentioned, that of our tradition, keeping in light in our tradition, we are not so much driven by consumption. And if there is a less consumption, there is a less waste, which we can see. For example, in India now we are in the middle income country. So we are generating far less waste as compared to the high income countries, which have much less population compared to our country. But because of the high capital intensive lifestyle, the consumption intensive lifestyle, the generation of waste is quite high. But the problem is that their population is less as compared to the space available. The other point is, of course, with the industrial growth, because we want our industries to grow, and we are getting into a lot of diverse fields, like from electronics to solar panels and everything. So these industries are also generating a lot of waste, which are also very quite difficult to handle and treat and dispose. Okay, so this industrial solid waste will also keep on growing as our industries grow, and we have to find means or method to how to handle these industrial solid waste, which also has in certain cases quite a good high amount of toxicity. And then comes the agricultural waste, which is, let's say, the least harmful of all this what we have talked about, and this is predominantly coming from our agricultural operations, the agriculture that is being carried out. So the part of the agricultural produce which is discarded, and part of the agricultural produce which actually goes bad because of the lack of preservation, because of lack of proper transport. So a bulk of agricultural waste is generated just because the produce does not reach from the field to the target consumer. So all these contributes to the agricultural waste, which also is quite high. And if you look here, there is a comparison with the in the countries, in the Asian countries, and you can see that we are almost just behind the China in terms of the agricultural waste and agricultural waste, which includes the animal waste also, and we can also separate it into the crop residue. So in both the counts, we have quite a good we have a big bulk in terms of the million tons, right? We have a big bulk of agricultural waste which is quite high. And when we say waste, again the question comes, so is this really waste or is there some wealth in it? Okay, now as already we have been hearing about recycling. So what is the why we need to recycle? So thing is that the simplest thing is, if we have a linear economy, which is only possible if we have infinite resources, and we have the earth ultimately has an infinite capacity to regenerate or produce those resources. So in that case, what we can do is we can just take the resources from earth, make or do the production and waste. But that is not the case. We know that we do not have infinite resources, and thus we cannot go for the linear economy. So the need of the hour is to have a circular economy where you are able to, you can use or actually reuse the materials and waste with a minimum. The minimum amount of waste should go out, right? Whatever you have, you should try to, if possible, reform it. We should try to reduce our consumption, and we should try to reuse, or which is basically the recycle, right, process. And out of this recycle or this circular economy, the minimum should go out as a waste, because only if we are able to do this, we will be able to reduce the amount of waste that we have to finally dispose of, or we finally need to handle. So the focus should be, as already mentioned, should be on maximum on the recycle or reuse of the materials. But having done that, still some part will go out as waste. Now what to do with that? So one basic thing, and which I want to highlight, or which probably every one of us present here can make a contribution, is in the waste segregation. This is very, very important. In India, we still do not have a proper mechanism of waste segregation. And even if waste segregation is there, maybe people are not fully aware of the importance of the waste segregation. So waste segregation is the biggest or the first step, and a step which we all can take to convert the waste into wealth. So waste segregation, you are all aware of that, separating the different kinds of wastes into different categories so that they can be treated according to their nature. That is very, very important for any kind of waste conversion to wealth. Waste segregation is very, very important, and this is the first step, and this is also the most challenging step, because this is which leads, this can cause to fail any technology. Whatever technology you develop, if you cannot have a technology which can handle all sorts of waste. Okay, so the waste segregation is very important for the technology to run perfectly. And if we see here that the framework for the waste management will, as I mentioned, we should consist of mostly recycling as much as possible. And of course, you will have certain materials which cannot be recycled or are hazardous. And you have certain materials which are biodegradable and then can be easily recycled. So what we need to do is, as I said, that first of all, as our it is inbuilt in our society, that we should reduce the consumption as much as possible, and whatever is possible to reuse, we should reuse, and whatever is left as a waste, we should try to convert into the wealth. Okay, and that is how this the cascade goes. So this is an inverted pyramid, that the most favorable option is the prevention, right? Same thing if we talk about a disease, the first option is you should prevent a disease, right? And then only the last option you should go about the treatment. So the first option is to prevent the waste generation, and whatever is possible to reuse, recycle and recover. And then finally, whatever you cannot do, reuse, recycle, recover, you need to dispose of. But while disposing of, what can be done to get the last mile, but that is an option. But of course, we should try to recover as much as possible before finally discarding it. So wealth, we all know, right? I mean, which has an economic value, which has a monetary value. So if we want to see from that perspective, that what is the waste to wealth means, and if we talk about some numbers, so what we see here is that in India, if we just talk about urban areas where data is, collection is more robust, we are generating huge waste, municipal solid waste every day. Okay, out of these, almost a significant percentage is the organic waste. And these organic waste, as you are aware, has, if you dump it, without any treatment, untreated waste, it will be decaying off and it will be giving off methane, which is also has a tremendous global warming potential, and carbon dioxide. Okay, so if you can treat this biodegradable waste, then, and by treating this waste, we can produce something called as bio-CNG, which I will talk in the subsequent slide. And this bio-CNG has a tremendous market value because this is a fuel. So you are already aware of the compressed natural gas, which is used in transport, which is used in industries, right? For energy generation production, you burn the bio-CNG gas, right? So this biodegradable waste, if you treat with it appropriate technology, then you can generate bio-CNG, which has a commercial value. And it is estimated that the yearly revenue that you can get out of this is 55,000 crores. So this, what we traditionally view as waste, has a economic value, or can be thought of as a wealth, if you can properly segregate the waste, if you can properly treat the waste with appropriate technology and get the fuel, and the fuel is has a economic value, has a monetary value. So we have heard about biofuels, right? So where you basically use a biological carbon fixation in the presence of sunlight. Okay, unlike the fossil fuels, which are formed and which are not renewable, right? They're non-renewable sources and they're not infinite resources. But the biofuels are kind of a renewable source of energy, and they can be replenished in a short period of time. One of these biofuels is the biogas, which you are already aware of, and you have heard it started a long time back, but has not caught up in a big way. But this biogas is very simple to produce, and it's a very well-known technology. People can see it, biogas plants existing. Of course, there are certain challenges in the operation, certain challenges in maintenance of those plants, but they are running well over the period of time. And they are basically, what you are doing is you are doing anaerobic digestion of the organic matter, and you are producing gas which has a calorific value in terms behaves as a fuel. Of course, this gas has contains methane and CO2. So the methane, or the natural gas, which is actually known as natural gas, is the one which burns or has the calorific value. But because you have a significant percentage of CO2, carbon dioxide, almost 40%, it can go up to that. So that actually reduces the calorific value of the total gas mixture, and it cannot be readily used for the applications which we are using the natural gas. Okay. So if we talk, I am skipping the process, the details of biogas production, because this is too much of technical details. But as we know that, as I said, that the end process is that the conversion, the anaerobic digestion of the organic matter to produce methane and carbon dioxide with them as main constituents. Okay, now the point is that we can produce the same kind of a gas from the municipal solid waste. But as I've already mentioned, that the major problem in this is that to treat that municipal solid waste, it has to be segregated into organic and inorganic, because the methane or the biogas that is produced comes from the organic part of the waste. So we should be focusing on the source segregation, because once the waste is collected and mixed, it is very difficult to segregate. It's quite difficult, right, to segregate it. So the segregation at source should be very much implemented, because that's what will help us to convert this organic part of the solid waste into the wealth, that is the biogas. So other challenges are there. Of course, the composition of waste keeps on changing, right? Throughout the year, we have different seasons, different kind of produces, agriculture produces different kinds of things and all that. So things on depending on the humidity and all these things, a lot of things keeps on changing, but that can be still handled. That can be still handled with proper the conditioning of the equipment in terms of temperature and composition of the bacteria. Okay, but many such procedures has failed also. Like for example, like I put an example of in Bangalore city, because of not proper waste segregation, and the plants have failed to operate. Okay, so the net bio-CNG potential that can be got from municipal solid waste, we are utilizing a very small percentage of that currently. So it's only 2.5% of the wealth that is available or that can be extracted from the municipal solid waste. Now talking about the bio-CNG, so this is actually the compressed natural gas and obtained by purifying the biogas. So this is called bio-CNG, and there is a lot of focus currently on this. Government is pursuing aggressively several schemes, entrepreneurships, and I think all the major oil companies, they are into doing this bio-CNG. So the bio-CNG composition, as we can see here, that the biogas has a wide range of methane in a fluctuation, and the methane is, and on an average you can say 60%, and this is the fuel, the thing which produces to give energy. And we have a significant amount of carbon dioxide which has to be actually removed from the biogas to be making it useful. We have also other components and sulfur and all these things which are also undesirable impurities on the raw gas. Now, as per the Indian standards, the bio-CNG should have at least 90% of methane, and the rest 10% can be CO2, nitrogen, oxygen, and all these things, and with a very minimum percentage of sulfur. So this is what we have to achieve. So what people are doing now is to purify the biogas or actually enrich the biogas. So enrichment of the biogas is, of course, involves two things. First is removal of CO2 so that the volumetric concentration of methane becomes high, up to 90%, as we have discussed, so that it can be burned in the existing systems. It can be furnaces, it can be the natural gas fuel transport systems, electric generators, whatever. So the removal of CO2s, there are a lot of different techniques: pressure swing adsorption, water scrubbing, monoethyl amine systems. So each one has different advantages, disadvantages, and all of them are capable of ultimately increasing the methane content in the upgraded gas. Of course, this will consume energy, but when we are able to generate the energy from the waste, this is offset, or this input cost is absorbed. The other thing is the H2S, which is also quite corrosive, so this has to be also removed. Again, different methods are there: water scrubbing, activated carbon. These are quite common methods, and each one of them has different complexity and cost. So these are choices, but technology is available. And using these technologies, once you have the biogas, it can be enriched or purified to the bio-CNG having 90% of methane. Okay, so this is just a layout showing that what we can do. We can set up such similar systems, and the beauty of this thing is that it can be a distributed system also. It need not be centralized things, because India being a very vast country with different geographies and all these things, different crops and different waste residues, it's very difficult to plan centralized things, because centralized big things are difficult to maintain and handle. So bio-CNG initiative, as I mentioned already, that it has been mandated that the municipal solid waste should be treated and used to produce this kind of energy, and the central financial assistance are available for the entrepreneurs going into bio-CNG concepts, and this has been also mandated for use in motor vehicles instead of the compressed natural gas, which is already being used. So these initiatives are helping for the uptake of the bio-CNG. Coming up with example, this is already operational. The biggest bio-CNG plant is running in Indore, and as many of you will be aware that Indore has been receiving the award of the cleanest city of India quite a number of times consecutively. And what it has done is that it has set up this kind of a plant in PPP model, and it processes it collects the garbage from the city, and using that municipal solid waste, it produces 17,000 kg of bio-CNG, which again the Indore Municipal Corporation buys back and runs city bus or sells it in the market. But this is only possible because the Indore Municipal Corporation has ensured 100% segregation of the waste at household level. So this is very, very critical for this technology. So to conclude, what we need to do is that we need to find new pathways, new technologies for sustainable development so that nothing goes to waste. Actually, you can virtually, I mean, there will be no term as a waste if the ideal thing happens. Okay, this is only possible if the segregation of waste is done, and we have to develop these technologies for converting this waste to wealth. For different processes, different routes are there, gasification, biogas production, lots of things. And lastly, we also need to develop technologies to use these biofuels or low calorific value gases, because the production is not enough. You need to do the uptake, you need to sell it, you need to actually do the last mile extraction. And this is where the research and development processes comes in. For example, we at IIT Jodhpur are working on a biogas driven micro gas turbine funded by PCRA. We are working in this field. So with this, I would like to conclude my talk, and thank you for your attention.
Thank you very much, sir.
Thank you.
Thanks for the wonderful session highlighting the types of waste, the circular economy, its importance, why segregation of waste is actually important for technology to run, the hierarchy of waste management, biogas and bio-CNG, the initiatives and the associated challenges, and very aptly summarizing whether what we are calling a waste is really a waste or we have got ways to convert it to wealth. Thank you so much, sir. So we can have a quick round of 1 or 2 questions if we have any questions.
Can I one question to Dr. Sudipto Mughopadhyay, sir?
Yeah, sure.
Sir, recently near Cochin, there is a waste plant, Brahmapuram plant, which caught fire 6 days, 7 days, and creating lot of pollution problems to all the people. They're told because of methane, because of high temperature during summer, methane is produced, and this is a common thing in many places. Just want to know whether it is true or it is possible.
Yes. So if you have seen that, I have put those figures in my slide, that untreated waste has a tremendous global warming potential because it releases methane and CO2. So methane is released because that's what we are doing actually when we are converting the municipal solid waste or any agriculture, any organic matter waste into biogas. We are actually converting it into methane, and that methane comes along with CO2. The CO2 is not the usable part, so we have to discard it, we have to take it out, enrich it and use it in the system. So methane is always produced, and methane is the wealth. So I mean, if you have traditionally, as I give an example in the Mumbai, right? I mean, so it's 300 football fields. That is the area of the dump site. So when you dump the waste, and it contains organic matter, inorganic matter as well as. So this organic matter, under the conditions of the natural process also, it can start liberating methane. And if you just need a spark to keep it burning, because there's a tremendous amount of gas. So what we are saying is, or what is the proposition is that you should use this waste to extract the gas and burn it in a controlled way. We don't want that uncontrolled 7 days of burning, right?
Thank you, doctor.
Thank you, sir. So in case we don't have any further questions, I would now request Director PS PCRA, Shri Avdesh Pandey, sir, to conclude the session and for a vote of thanks.
Thanks, Anupriya. Am I audible and visible?
Yes, sir, loud and clear.
So, our dear all 3 respected speakers and all our dear colleagues, friends, and all the attendees of this webinar. So today's session was very full of knowledge, and very informative and very interesting. So as friend, it is a very common topic. Is everybody is having some knowledge, some other knowledge about this topic. As we all know, the rapidly growing income, increasing, rising economy, but unplanned urbanization and our changing lifestyles have resulted in increased volume and changing composition of the waste in our country particularly. And improper waste management in India has uh, numerous implications on environment as well as health. Over the years and decades, we have created so many categories of the waste like solid waste, e-waste, liquid waste, plastic waste, metal waste, nuclear waste, and further they can also be categorized as a wet waste, dry waste. Means one is biodegradable, and other is non-biodegradable. So there are several issues involved in the waste management in our country. First of all is the local bodies, municipalities, they are having insufficient waste management infrastructure. Then there is a lack of segregation of different type waste, like household waste, industry waste. So which results in the uh, increasing this piles of the waste. Uh, then there is the unsustainable packaging, because with the popularity of this online retail and food delivery, e-commerce companies, all these are contributing to the rise in the plastic waste. Then there is a rising rural-urban conflict. This urban waste is dumped in the outskirts, which is the village area, rural area. So that creates health and environment issues for these villages. So our government has recently has taken some initiatives regarding waste management, like one national dashboard on elimination of single-use plastic and plastic waste management has been created. Government has made a plastic waste management amendment rules 2022. There is a project replan uh, and mascot prakriti. There are several initiatives government has taken, which are binding also, and which need the participation from all the populace. So there are two-pronged technologies required. One is short-term attention, and second is a long-term strategy to address the future challenges of waste management in Indian cities, particularly. So I think there are some way forwards, like the producers. This should have the extended responsibility. There should be some mechanism that producers should be responsible financially to reuse their waste and uh, their life cycle, various parts of life cycle for of their product. Then there should be decentralized waste management. This at community level, there should be waste management system. So it will reduce the cost of transportation of waste from one place to other place, and also it will reduce the burden of handling large volumes of the municipal waste. Then there should be technology-driven recycling. Means government should encourage research and development in the field of waste recycling at the technical universities to promote the active participation of masses in the technology enhancement in the field of waste management. And overall, as a responsible citizen, we should try to minimize the waste creation